Marquette Energy Analytics, and this is our summer webinar, Early Frost, Forecasting Fall Heating Days, MCAS Gas Day. So I just wanted to share a little bit about who we are. We have some people we haven't talked to before attending this webinar. So we're Marquette Energy Analytics, where our office is in Milwaukee, Wisconsin, and our passion is to transform energy-related data into easy, reliable, and innovative decision support tools. So with everything that we do, those three words, easy, reliable, and innovative, kind of capture what we try to put into everything. So we have a lot of products, but I'll talk about two real quick. We have MCAS, that's a suite of forecasting tools, natural gas demand forecasting tools, and power. And on that, we forecast daily, hourly, and at annual timescales. So depending on your energy needs, we probably have forecasting tools that can help support your operations. The other thing that we do that's very common with this crowd is design day studies. So that's looking at a much larger horizon, 1 in 20, 1 in 30 years, whatever it is that your utility requires. And we find the peak use day, so we call that design day, and it's design day studies. Yep, so that's about us. I want to do a shout out of our 2024 Gas Forecasters Forum. It's in Charlotte, North Carolina, September 30th to October 2nd, so it's coming up. I would like to see as many people as we can join us there. Our spots are filling up after this webinar. I'll be sure to send everybody a link to register for that. Some of our speakers there at the bottom, Tom Quinn, Dr. Ron Brown, Sarah Grotman, Greg, who will be giving today's webinar. So we're trying to make this the best industry event for people who use and make natural gas forecasts. It's very targeted, it's very specific, and we're trying to make it, like I said, the best event in the industry for the kind of people that we work with and that we are. So hopefully we'll see you there. This is Greg Merkel. He's our data team leader at MEA. He'll be doing the larger portion of this presentation. So before we get into that, I want to give a little introduction. Greg Merkel is the data team leader at Marquette Energy Analytics. He has spent over 10 years in the natural gas industry. Merkel started at Marquette's Gas Day Lab as a research assistant in 2013, spent 5 years pushing the boundaries of demand modeling and mathematical demand modeling under the tutelage of Dr. Richard Borvinelli, Dr. Ron Brown. In recent years, he developed MCAS Power, our electric power forecasting solution. Merkel is the man behind a lot of the design day study work that we do. He also continues to make improvements to all of MEA's forecasting solutions. At the bottom of the screen, info at Marquette Energy Analytics. You'll probably see a couple emails throughout this webinar, but that's a good one if you have any questions about anything we talked about. Getting half this presentation or anything you see in the second half, that's a great place to reach out. We'll direct you from that email to whoever's best to answer your question. So I'm going to stop sharing here so that Greg can take it away with his presentation. Thank you again for joining, everybody. I see that we now have a full audience ready for you, Greg. So go ahead and take it away.
Sounds good. As we're going through this, feel free to ask questions in the chat. I think Alex, let me know if anything pops up there, and I'll try to answer. Our talk today is really kind of going to cover two separate but related topics related to fall heating degree days. The first one is, how is fall gas demand changing in our changing climate? To look at that, we're going to be investigating normal weather and when our first cold days are occurring. And then we're also going to talk about what MCAS Gas Day does to forecast those first cold days. It's going to be a little bit more of a modeling side talk. We're going to talk about prior day effects and some other techniques that we use to forecast well when it first gets cold. Okay, so I'm going to start with a kind of a micro view of things. Um, we're going to look here. I'm looking at um, Milwaukee, but later in the presentation, we're going to expand that out and look at, you know, a lot of places across the country. Um, Milwaukee, of course, is close to home for me. The weather that is in this data set is recorded about 2 miles south, so it's literally very close to home. Um, so this graph um, on the y-axis here, that's our daily average temperature, and on the x-axis, we have arranged that data from July 1st through June 30th, kind of to focus the winter in the middle. And the yellow data points are every temperature reading for the Milwaukee weather station from 1973 to present. The blue line is our normal weather calculation for Milwaukee. We calculate that normal by, well, in this case, it's a 20-year normal, so we're going to be looking at the weather data from 2004 to 2024, taking the average of each day of the year, what was the temperature on that day, and then we apply a low S smoothing algorithm to that to, give it a nice smooth curve look. I've also marked on here a couple of interesting data points, which are these two horizontal or vertical lines, I should say, that are basically, between there is the 121 normal coldest days. So that's going to be, where the actual winter falls for Milwaukee. And then the X is the coldest normal day, meaning, that's about when we're going to be expecting the highest peak days, which is falling right now, right around the end of January. But we're talking about climate change. So looking at the 20 years by itself isn't going to give us a ton of information. So here I've plotted, in addition to that 20-year normal, which is in blue, I also have plotted a 30-year normal in green and a 10-year normal in red. Um, Now, what you'll notice is that while the 30-year and the 20-year normal kind of lay pretty much on top of each other, there is a notable difference when it comes to that 10-year normal. The red line, especially you can see it in the winter, is certainly warmer than when we're looking at longer stretches of data. In addition, we see here in the fall, which is going to be where we're mostly focusing our talk today, that the 10-year normal is warmer than the 20 or 30-year normal. Now, I want to be clear, I'm not necessarily recommending that folks use a 10-year normal as opposed to a 20 or 30-year normal, but this kind of shows, the 10-year normal is a little more reactive. So it adjusts more quickly to changes in the climate. To make this stand out a little bit more and, take advantage of the fact that a 10-year normal is more reactive, I have plotted two 10-year normals on the graph. The red line, which is the same as the one that we just showed, and that's our 10-year normal from 2014 through 2024. And then a blue line, which is the 2009 to 2019. So there's 5 years of overlap. We got 5 years afterwards that are unique to the red trace. And here we start to see, our normal weather is changing. That 5 years, that this last 5 years has been warmer than we might have expected based on a 10-year normal that ended in 2019. Now, this is the part where I acknowledge that there's a lot of interesting things to talk about here. That's when our main load is going to occur is in the winter. But for the purposes of kind of containing this conversation, we're actually going to be focusing here on the fall and talking about, well, what are the effects we're going to start seeing coming up in September, October, November. So let's zoom in a little bit. The yellow, red, and blue lines are the same ones as on that last graph. Um, but I've added a couple of others. I've added a line here that's at 65 degrees. So that's typically where people are going to start calculating their heating degree days, which I've included the calculation here. That's a typical way that people will evaluate, how much demand there's going to be is looking at, well, how many HDDs are there? But generally speaking, we don't necessarily see everybody turning their furnaces on as soon as the daily average temperature drops below 65 degrees. Usually happens somewhere between 65 and 55, where I have this other dark line. But once we get below that 55 degrees, that's when we start seeing most people having their furnaces on. As it gets colder, there's a much more linear relationship between the temperature going down and the demand going up. The place where I kind of focus our interest here is looking at what are the total HDDs for various time periods. So if we look at, say, September here, well, I'll start with August. If we're looking at normal total HDDs, the red and blue lines are never crossing the black. So we're not having any normal HDDs. That doesn't mean that we can't have heating degree days. Obviously, there are temperature data points here, the yellow marks here. But there's certainly not a ton of them. If we go on to September, though, towards the end of the month, we start seeing normal temperatures below 65 degrees. So essentially, this space, I'll start with talking about the 10-year normal ending in 2019. We've got a triangle here formed by the end of the month, the blue line and the black line. And the area of that triangle is essentially that total normal expected heating degree days for the month. And then if we look at the red line, we've got a much smaller triangle that we're working with. So, that's going to be a difference in our expected demand. Likewise, in October, we see this space here. And while it's not as pronounced in terms of percentage wise, this whole sliver, like in between the red and blue line, that marks a change in the total demand that can be expected in October. Might be a little bit easier to visualize that here. Actually, I guess should talk about November too. You can kind of see that there's not a ton of difference in November. And if we look at the sum of those HDDs, it checks out. It matches what we saw earlier. Our September heating degree days here are down, basically almost non-existent from there being at least a couple before. October, we're seeing a big drop, and then not a ton here in November. So it's certainly a more pronounced effect when we look at September and October. We can also look at this another way, which is to analyze when our first cold days occur. So this graph is, we've got our year on the x-axis. So this is showing over time. And then each, you know, on the y-axis, we've got the day of the year. And so what we're looking at is when was the first day that the daily average temperature was below 65 degrees. And if we look at the observed, ignore the expected for now, we can see how, up until about 2005 here, it was fairly common for us to get that first kind of cold day as early August. Sometimes we're looking at late August, early September, but we have a lot of days that are down here, or a lot of years where it happened early. But if we start looking, 2010 and beyond, yeah, still maybe once every 3 years or so, we're getting an early-ish cold day. But those, you know, the average is certainly getting later, and we're starting to see, this, 2021 didn't happen until mid-September. I've also plotted on here a green line. That's our essentially a moving average of the observed first cold days. Where this gets a little bit more stark is when we look at when those first below 55 degrees Fahrenheit days occur here in Milwaukee. So, we're looking at, the grid line here is a week. So each jump here is a week. And we can see that for the most part, most of the time, up until about 2015, that first day where the temperature dipped below 55 degrees here in Milwaukee occurred between September 16th and September 23rd. So mid to late September. Obviously, there's some outliers. A couple times it's early September, a couple times it's later in September, maybe early October. But for the most part, we're looking at mid-September. However, starting in 2015, that has clearly changed. Now we're looking at that first cold day usually happening right around the end of September or early October. Obviously, again, sometimes it's a little different. Sometimes it's as late as mid to late October. And then you can see that reflected in the expected line. So, the expected sits right around the middle of the month, and then starting in 2010 starts to creep upwards. I think it's important to point out that, because of the way this is being calculated, like the observed data is very much looks to me like we have a steady state, and then we jump and are at a steady state again. I do not necessarily think you can just like follow this line up to predict where we're going, but it does show, we've got these days are coming later. So that's the micro view, looking at just one location. I want to pause here and make sure there's no questions about where we've gotten so far.
Thanks, Greg. Everybody, if you want to ask a question using your mic, you can raise your hand. It should be the button on the middle of your Zoom panel there. Another way to ask is the Q&A button. That'll allow you to submit questions for me to answer. We'll give it a second.
Sure.
I do have one question already.
Okay.
So they're asking if we use 20 or 30-year normals.
So we typically default to 20-year normal when we're doing any calculations with normal weather. And that there are historical reasons for that. However, we also, will tend to do what our customers are asking for. So if you use a 30-year normal internally, we'll use a 30-year normal for what we're calculating.
All right, here's another question. On this graph, is 55 degrees daily average or 55 degrees at some point during the day?
Daily average.
All right, thanks. I'll let you know if any others pop up, but again, if
Sounds good.
anybody wants to say anything, raise your hand or use that Q&A button.
Yeah, great.
Back to you, Greg.
Yeah, so let's expand this out a little bit and look at the Midwest as a whole. So I'm looking at 6 weather stations. This is Kansas City, Minneapolis, Milwaukee, Chicago, Detroit, and Cincinnati to try and get a good spread. As a Midwesterner, if you disagree with, what I've called Midwest here, that's fine. Send me an email later. But if we look at the average, so, again, we're going to be looking at that normal heating degree day. We look at the averages across those 6 weather stations, we're seeing pretty similar results to what we saw in Milwaukee. September and October, and September is going from a little bit to basically nothing. October's dropped a little bit, and November is pretty much the same. I mean, there may be a little bit that it's saying it's, getting slightly colder in the last 10 years compared to the 5-year offset, but it's pretty small, especially when you consider like a percentage change. And if we look at, so then now I've pulled the expected line from those overtime graphs that I was showing earlier. And I've plotted them for all 6 of those weather stations. Now I've got Milwaukee here in the blue, and this is the 65-degree one. Our scale has changed slightly. We're only 3 days between grid points instead of a full week, so I don't want to mislead anyone with how this graph is. And we can see, generally speaking, a pretty similar trend in other places to what we saw in Milwaukee. Obviously, like someone like Minnesota is maybe not as pronounced, or Minneapolis is not as pronounced. Kansas City is a pretty, we have a big dip in the 80s, but it's kind of back where it started in the 70s. Detroit has this big dip, but has been going back up later. But in general, we're seeing a trend of these first cold days happening later. If we look at 55 degrees, again, the effect is a little bit more pronounced, where we're saying, like with Milwaukee here in the blue, I don't think it should be terribly surprising that Chicago is pretty similar. But even places that are as far away as Cincinnati or Kansas City are acting similar, where, up until 2005, 2010, it was at a pretty steady state. And then, 2010 on, it jumped up. And similar to what I saw in Milwaukee, if I had all the observes on here, which makes this graph a total mess, so that's why I didn't put them on here. It's a similar effect where, on the Milwaukee one, we saw it was more of a step up as opposed to a gradual increase. But if we expand that view out even more, let's look at the Northeast, see how that compares to what we saw in the Midwest. We're going to be looking at these 5 weather stations. I tried to get a mix of, a couple on the coast, a couple of inland, and at least a decent variety of latitudes. And the results are pretty similar to what we saw in the Midwest. Maybe we're not as pronounced of a drop off in September, but October looks similar. And then November is pretty unchanged between the two views. And then again, if we look at, the trend in those 65, those first 65-degree days, we're seeing, kind of across the board a steady line. And again, I'm going to point out we're back to looking at a week scale on the y-axis. The first cold day in Albany and Buffalo, again, should be fairly well correlated there, started to creep up. New York has a big effect here where we're seeing, as much as happening 3 weeks later on average compared to back in 2000. And then again, looking at the first 55-degree day, we're also seeing those slopes. Nothing as pronounced as that first 65-degree day that we were seeing in New York, but we're still moving back a week over the course of the data set. And again, we're seeing a bit of a plateau here and then curving up in places. And that's pretty typical. We can also look at this in the South. You know, these are the places we're going to be looking at, or the weather stations we're going to be looking at. We got Nashville and Charlotte, Jackson, New Orleans, Houston, and Dallas. And while, we're looking at much warmer areas of the country, October and November here are behaving pretty similarly to what we saw up north in September and October. And that's reflected again in our first cold days. I don't think it should be terribly surprising that New Orleans, Houston, and Dallas kind of go all together. They're very much in line. But that first kind of cold day, 65-degree Fahrenheit, is moving back a week or two compared to where it was a couple decades ago. Certainly less, I don't see any effect here in Jackson, and maybe a little bit of that more recent effect in Nashville. But that kind of makes sense. Nashville is going to be a lot more closely tied to the Midwestern areas we were looking at earlier, as opposed to some of the southern ones. And obviously, Charlotte, has some rise, but it seems like a lot of that happened earlier on, and it has flattened out. Looking at the 55-degree trend, not as much here. Our three, Houston, Dallas, and New Orleans are pretty much flatlined, if not going down a little bit. It's a couple days, 3 days here that we're looking at between start and finish. But we certainly see a more pronounced effect on the previous slide, we didn't have any effect in Jackson and not a ton in Charlotte, but we're seeing a lot more here when we're talking about when are those first, like, really, strong heating days going to occur. I will point out that this implies to me that at the beginning of October, end of September, we should still have some fairly nice weather in Charlotte for the Gas Forecasters Forum. And then if we look out west, I will admit, kind of jammed a bunch of topographies and climate zones together for this last one. We've got some desert areas in Phoenix, Albuquerque, and Las Vegas, and also, the Pacific Northwest up in Seattle. But we can still make some broad conclusions here. If we look at the average normal heating degree days by month, um, for those 7 stations put together, August and September look very similar to the September that we've seen before. October looks very similar to what we saw in the Midwest and Northeast. And November, once again, we're not seeing a ton of change. And then if we look at, the change in those first days over time, again, uh, we're maybe not seeing as much on this graph. Obviously, our scale has changed again. And we're looking at, because we're looking at such a diverse set of areas, we've spread out to, having a month between grid lines. But in general, these are all fairly flat over time, with the exception of Denver, and to a lesser extent, Seattle. Um, again, Denver being much closer to the Midwest, it's going to see similar patterns to what we saw there. But we are seeing, some effects here when it comes to when are those first really cold days going to happen. Maybe a week and a half or two across the board here, with the exception of Albuquerque, which is pretty flatlined. Which brings me to some of my conclusions for this first half of the talk, which is, I mean, the big one is normal weather is changing. Um, you know, we're well, I'll come back to it. And the other one is, those first cold days, when that's going to roll in, is happening later and later for almost everyone compared to what we've seen historically. And if I could, have people take away one thing from this talk, it's that relying on historical observed weather as a predictor of what we're going to see in the future is becoming a less reliable task. And we're seeing this in, both of the ways we looked at data, both the normal weather and those first cold days, point to, things are changing. We're not going to be able to rely on normal weather as much in the way that we calculate it for predicting our gas demand. And then going forward, we want to investigate, well, how does, we talked mostly about weather today. How does that change in the weather? How is that going to affect our fall and spring supply planning and hedging and those sorts of activities? And then, of course, our impact on design day events. I will say this is not going to be the last time we're going to talk about climate change. I know one of the talks, well, the talk that Ron Brown is going to give at Gas Forecasters Forum is basically going to be taking the climate forecast and trying to determine from that, how do we want to adjust our normal weather or our design day forecasts to account for the expected change in weather going forward. I put a couple of email addresses on this slide. Our data at Marquette Energy Analytics, that goes to me and my team. Info is a more broad one that you can reach out to as well. I only was able to cover some regions or some individual weather stations. If you're a gas day customer, we've done design day studies for and those sorts of things. It's pretty easy for me to generate some of these slides if you want it for one of your particular weather stations. Um, or if you have any questions about the stuff we showed today. So the second half is going to be, somewhat related. We're going to talk about, well, how does MCAS forecast those first cold days? I always like to start with a pretty simple graph here where we've got, again, our daily average temperature on the x-axis and our demand on the y. This is fictitious data that we've put together for, that we're calling system. And this is a pretty typical way to view gas demand data. But for the purpose of this talk, we're not really caring too much about, well, all days. We want to focus on, forecasting those first cold days. I've got my heating degree day calculation here, but the way we're going to define our first cold day is going to be days where the HDD, the heating degree day, is greater than 0, and the prior 2 days do not have any heating degree days at all. So this is that same data. I've flipped the graph around. The x-axis is now heating degree day, or more accurately, 65 minus the daily average temperature. And then I've highlighted our first cold days here in yellow. We're going to fit a model to that. So this green line represents a pretty basic gas forecasting model where, our demand equals our base load time, or our base load plus our heating degree days times our use per heating degree days. And this model does okay. It's going to get 12% error on all days, but it's going to do pretty terribly on those first cold days with a 25% error, which is not very good. And we can sort of see why that happens if we look at our graph here, where our green line is well above where the majority of these yellow points are. So how can we make this better? Well, the first way we can make it better, and this is something we do for all of our modeling, is we can use multiple heating degree day terms. And it's part of why we look at those HDD 55 is because we use it as part of our modeling, because we know at temperatures below 55 degrees, we've got a much more linear fit. So if I hop back here, you can kind of see that. 55 degrees is going to sit right around here. You can see that by the time we get to there, we're much more linear relationship to the right of that than this chunk here, where we're maybe not as linear. That's part of why our green model is not doing very well. But adding this second heating degree day term helps our model in a bunch of ways, largely because, if we've got just the one heating degree day term, essentially have a lever, that we can work with. But if we're doing 2, we've got 2 points, and it gives us a little more freedom to move around. And so with those extra degrees of freedom, we're going to fit better on shoulder days. So that's going to help us a little bit on the cold days. And, not as important for this talk, but generally speaking, this does better on design days. In addition, we're going to give ourselves another degree of freedom by adding a cooling degree day term. And so I've plotted this 4-parameter model over our data set in this gray line. You can see, we're tracing along. We've got this, two places where it bends, and we've got a slope here going out on the cooling side of things. And overall, this definitely improves our forecast. On all days, we've dropped our error down to an 8% error. but we're still not doing great on the first cold days. An 18% error is certainly better than the 25 that we were getting before, but it's still not amazing. And if you look at our graph here, you can see why. We're still fairly wildly over forecasting the average first cold day. And that's obviously gonna drive up our error. Um, so what can we do to do better here? This is where our fifth parameter to our model comes in. So um, essentially, what we're doing is we're taking the mean or the average of our HDD 65 and HD 55, and we're saying, well, today's average heating degree day minus yesterday's heating degree day. So we're adding this additional bit of information to our model. So our model knows, well, how much warmer or colder is today than yesterday. And essentially, this is going to allow us to subtract out some of our forecast because yesterday's heating degree days were less than today's on these first cold days. This is going to help out our forecast a lot, but it specifically helps a ton on those first cold days. And so I've plotted that in the red. If you look at our results here, it's dropped our error from 8% to 6%, and our first cold days have been cut in half from 18 to 9.3, which is a big improvement. But if you look at the graph itself, you might be skeptical of those results because this red line is still sitting well above those first cold days. And the reason for that is because this red line is kind of a slice of a 3D model. We're only plotting today's daily average temperature versus demand. So this line here is really more like, well, what if today's demand and yesterday's demand were the same? This next part, it's a little bit easier if we zoom in. But if we instead plot, well, what does this line look like if yesterday's heating degree days equals 0? So yesterday's heating degree day equals 0, and then this, represents how many heating degree days there were day of. Well, now we've got a nice line that fits right through the middle of those first cold days. And that's why, using methods like this, we're able to forecast well when those first cold days happen, where a simpler model probably is going to over forecast most of the time. We're not done there. We apply a couple of other treatments. First one is we weight the first cold days more heavily. Well, we weight a lot of different types of days more heavily when we're doing our modeling. So we don't get a ton of cold days, like super cold days, and we don't get a ton of these first cold days and a bunch of other more unusual situations. And so we weight those data points more heavily so that our models can forecast better on the rarer events rather than doing really well on your average day and then doing poorly on odd days like these first cold days. In addition, there's a little bit of MEA secret sauce going on here, in a similar way to how my presentation's been redacted a little bit. There's in a similar way to how we were looking at, well, how does yesterday's demand affect, or yesterday's temperature affect today's demand? We can also then look at, well, what did 2 days ago's temperature? How is that affecting? And what is the cumulative effect of, well, 3 days ago and 4 days ago, and as that thermodynamics of you know the temperature through walls, of homes comes into play. And in addition, we do, some other modeling stuff that helps us across the board, like accounting for day of week and day of year, etc. And with all of those things, we're able to cut down that error further. For this particular area, we're cutting our error on all days down to about 3%, and on those first cold days all the way down to 4. I will, note that all the metrics shown in this presentation about how well these models performed is on in-sample testing and on perfect weather, or, more accurately, observed weather. So this doesn't account for, well, how did the weather forecaster do, or other things like that are going to bring our error up. Although, notably, these are just for our linear regression model, not for the linear regression and ANN and all the ensembling that we do as well. So, with that, I'm gonna pass it off to Alex to plug the forecasters forum again.
Thanks, Greg. Like I was saying earlier, everyone, we have an event coming up in September and October, late September, early October in Charlotte. Love to see everyone there. If you like talks like this, that's the kind of stuff we'll be covering. Like Greg said earlier, Dr. Ron Brown, he's going to be looking at how climate change will affect our forecasts going forward. We have talks on AI. Our users group meeting is going to be taking place there. So a lot of good content. We have a lot of good speakers and topics. I think that'll be of interest to everyone. All right, thanks for sticking around with us. If anybody has any questions, they can ask them or raise their hand, or send us an email at that info email address there on the screen. I'll make sure this recording gets out to everybody in the next week. So if you want to look back or share, that'll be available for everyone. Thanks, Greg, for sharing your work with us today. That was interesting, really interesting.
Thanks for putting it together, Alex.
Yep. Oh, we have one hand raised, Greg.
Oh,
it went down. It was up and then down. Thanks for all the claps, everyone. We'll be doing some more webinars like this in the future, so stay tuned to our LinkedIn and get on our email list if you're not. So, yep. All right. I don't see any questions coming in. I think we'll end it there. All right.
All right.
Everyone have a good rest of your day. I'm sure we'll be talking soon. All right. Bye.